Hello friends. In this presentation we are going to discuss about the mesh matrix analysis. So what is mesh matrix analysis? Basically mesh is defined as a loop which does not contain any other loop within it. It is the smallest loop in the network. Mesh analysis is applicable only for the planar networks. A network is said to be planar if it can be drawn on a plane surface without crossover. If a network has a large number of voltage source, it is useful to use mesh analysis. This analysis consists of writing mesh equations by Kirchhoff's voltage law in terms of unknown mesh currents. So, steps to be followed while solving mesh analysis. First step is identify the mesh, then assign the direction to it and assign unknown currents in each mesh. Step 2. Assign the polarities for voltage across the branches. Third step indicates apply KVL in each mesh and use Ohm's law to express branch voltages in terms of unknown mesh current and the resistance. Fourth step, solve the simultaneous equations for unknown mesh current. So based on this, now we will practice some numericals. First numerical is with the independent source. Determine the current flowing through the 5 ohm resistor for the network shown below. So as per the steps, first of all we have to identify the meshes, then we will assign the mesh current, then we will assign the polarity to the source, voltage source, then we will write the KVL equation for each mesh and solve that equation simultaneously to get the appropriate result. So according to the steps, first of all we have identified three meshes: mesh 1, mesh 2, mesh 3. Mesh 1 with 8 volt voltage source, mesh 2 with 10 volt voltage source and mesh 3 with 12 volt voltage source, and we have assigned the clockwise direction of current for each mesh. For mesh 1, I1 current with clockwise direction. For mesh 2, I2 current with clockwise direction. And for mesh 3, I3 current with clockwise. So now we will apply Kirchhoff's voltage law to mesh 1. Since the battery polarity is minus and then plus, negative to positive voltage rises there. So it is represented by plus 8. So here it is shown simply 8. Then after that, 1 ohm resistor which is common between mesh 1 and mesh 2. So minus 1 I1 minus I2, then minus 2 I1 minus I3, third mesh current, and that is equal to 0. This is the basic KVL equation for mesh 1. So arranging this equation and call it as equation number 1. Then apply KVL to mesh 2. Then again the battery polarity is from negative to positive voltage rise. So it is represented by plus 10. After that 4 ohm resistor with a current of I2, that is minus 4 I2. Then 3 ohm resistor is common between mesh 2 and mesh 3. So I2 minus I3. Then 1 ohm resistor is common between mesh 2 and mesh 1. So it is minus 1. I2 minus I1 is equal to 0 is the basic KVL equation for mesh 2. Again arrange this equation and call it as equation number 2. Now apply KVL to mesh 3. Since 2 ohm resistor is common between mesh 3 and mesh 1, so it can be written like this: minus 2 I3 minus I1. Then 3 ohm resistor is common between mesh 3 and mesh 2. So it is written as minus 3 I3 minus I2, then minus 5 I3 plus 12 is equal to 0. Again arrange this equation and call it as equation 3. Now solve this equation number 1, 2 and 3. Then you will get the current I1, I2 and I3. Since it is asking current flowing through the 5 ohm resistor, that is current of mesh 3. So I3 is equal to 3.38 ampere. So this is the final answer for this numerical. Now we will discuss another numerical with dependent source. Previously we have solved the numerical with independent source. So while solving the numericals based on dependent source, you have to identify first of all the dependent sources, types of dependent sources. In this circuit, two meshes are there and two dependent sources are there. Both are voltage sources and the value of which depend on some another parameter, that is current. So it is called as a current controlled voltage source. So now we are assuming the direction of current. For mesh 1 I1, for mesh 2 I2. So mesh 1 current I1 can be called as IY, as IY is already flowing through the circuit. Mesh 2 current I2, which is flowing into the common branch between mesh 1 and mesh 2. So Ix is equal to I1 minus I2. So again apply KVL to mesh 1 with the same concept. So minus 5, which indicates the battery voltage of 5 volt. Then next 5 ohms resistor with a current of I1. So 5 I1 minus 2 Ix, then minus 4 I1 minus 1 I1 minus I2 plus 2 Iy is equal to 0. This is your basic KVL equation for mesh 1. Now you can substitute Ix with I1 minus I2 and again rearrange the equation so that you will get this final equation for mesh 1 as minus 10 I1 plus 3 I2 equal to 5. Call it as equation number 3. Now you apply KVL to mesh 2 and write the KVL equation. Minus 2 Iy minus 1 I2 minus I1 minus 2 I2 minus 10 equal to 0. This is your basic KVL equation for mesh 2. Arrange this equation, replace Iy with I1, then you will get equation number 4. Now you solve these equation 3 and 4 simultaneously. Then you will get the value of I1 and I2. Substitute the values in the equation 1 and 2. So the Ix will be 1.514 amperes. Next numerical. Again find the mesh current in the network shown. Again there are two dependent sources. They are voltage source and now the value is depend on the voltage only. So these voltages are called as voltage dependent voltage source. First voltage dependent voltage source is 2V2 where the location of V2 is in the another mesh. So before solving the numerical, assume the mesh current first. In the mesh 1, I am assuming that the current I1 is flowing and in the mesh 2, current I2 is flowing. So we will write the equation for V1 and V2 first. So according to Ohm's law, V is equal to IR. I means I1 is here for mesh 1 and resistance is 5 ohm in this mesh. So V1 is 5I1. But since the voltage polarity is opposite to the polarity of current, the negative sign is indicating here. So V1 is minus 5I1. Similarly, for V2, it is 2I2. Now apply KVL to mesh 1. Minus 5 minus 5I1 minus 2V2 minus 4I1 minus 1 I1 minus I2 plus 2V1 equal to 0. Replace V2 with 2I2 and V1 with minus 5I1 and get the equation 3. Then apply KVL to mesh 2 in the same way so that you will get equation number 4. Now solve these equation 3 and 4 simultaneously to get the value of I1 and I2. This is your final answer for the numerical. Few practice numericals for the same. Thank you.